In the world of AI, there are certain common sense fixes that pretty much everyone just accepts. But today, we're going to put one of the most popular techniques for fixing skewed data right under the microscope and find out why a team of researchers is sounding a pretty major alarm. So let's just start with that question. What if a popular fix for biased AI is actually making things worse? I mean, just imagine spending years using a tool you think is helping your AI make fairer, more accurate decisions, only to find out it might be secretly poisoning the well. That's the core mystery we are unpacking today. We're going to follow the evidence, the breadcrumbs laid out in a 2022 paper by Tarawneh and his colleagues. Now, these folks didn't just have a hunch. No, they designed a really clever experiment to put this whole technique on trial. So, let's see what happens when a tool everyone trusts gets put under the microscope. Okay, first things first. We need to really understand the problem everyone's trying to solve here. It's a classic challenge in machine learning, and you've probably heard it called the needle in a haystack problem. This is what's known as class imbalance, and it's pretty much exactly what it sounds like. It's what happens when you're training an AI and your data set is just, well, it's skewed. You have tons and tons of data for one outcome, we call that the majority class, and very, very little for the other, the minority class. And this chart just illustrates the issue perfectly. You might have, say, 99 examples of a negative result for every single positive result. Now, if you train an AI on this, it can learn a really lazy trick. Just guess negative every time. And hey, it'll be right 99% of the time. But in doing that, it completely fails to learn how to spot that one crucial minority case. And here's why this isn't just some technical headache. That minority class, that needle in the haystack, is almost always the thing we care about most. We want the AI to find the rare disease, to spot the single fraudulent transaction, or to find that one critical security breach. Getting these wrong has serious, real-world consequences. So for the past 2 decades, the AI community has pretty much rallied around what seems like a simple, elegant solution to this problem, a technique called oversampling. And the logic is incredibly intuitive, right? If your problem is that you don't have enough examples of the minority class, well, why not just create more of them? You take the few needles you have and you just generate new synthetic examples that look just like them. In practice, the whole process is pretty straightforward. The algorithm looks at the rare data, it creates new artificial data points that are statistically similar, and then it just adds them to the training set. And boom, your data set is no longer imbalanced and your model can, in theory at least, learn better. And believe me, this idea hasn't just been some niche theory. According to the paper, a Google Scholar's search for oversampling turns up nearly 300,000 results. It is an absolute cornerstone of machine learning practice. And this chart from the source paper says it all. I mean, look at that curve. The use of oversampling hasn't just grown, it has absolutely exploded. This has become the go-to solution for just about everyone. But this is where our story takes a very sharp turn. The researchers behind this paper, they looked at this exponential rise and they ask a very uncomfortable question. What if the data you're creating out of thin air isn't a perfect copy of the needle? What if it's actually something else entirely? What if you're not balancing your dataset, but you're polluting it? And they do not mince words. This is their central counterclaim, a direct quote right from the paper. They argue that oversampling is a misleading approach that feeds the learning process with falsified instances. Falsified instances. They're saying the synthetic data claims to be part of the minority class, but it just isn't. The danger here is profound. I mean, for any developer or data scientist, this is your absolute nightmare scenario. A model might look fantastic in the lab, right? It's showing high accuracy on the synthetic, balanced dataset. But then you deploy it in the real world to look at real patient data or real financial transactions, and it could fail spectacularly because it was trained on a lie. So how do you prove such a shocking claim? You can't just say it's wrong, you have to show it. And the researchers designed what I can only describe as an ingenious sting operation for algorithms. Now, I know this flowchart from their paper looks a little complex, but the idea behind it is absolutely brilliant. They created a system specifically to test whether the new synthetic data points were actually legitimate members of the minority class, or if they were imposters. Okay, let's walk through this. They start with a normal imbalanced data set. Then, here's the clever part. They take some of the majority data, the haystack, and they hide it. The oversampling algorithm never even sees it. Next, they run the oversampling method to create new needles. And finally, the big reveal. They unhide the majority data and compare. Is the newly created needle actually more similar to the real needles, or is it secretly more similar to the haystack it never even saw? The fear is that the sheer volume of the haystack data just warps the statistical space, pulling the new needles into its gravitational orbit. They ran this sting operation not just on one or two methods, but on a massive scale. And the results were, to put it mildly, damning. They tested over 70, that's 70, different oversampling methods. Everything from the most famous ones to the more obscure variants across 9 different real-world datasets. This wasn't a small-scale test, it was a comprehensive audit of the entire field. And here's the verdict. Not one or two methods failed, not most of them. Every single one of the more than 70 methods they tested was found to generate faulty synthetic examples. In every case, some of the data that was supposed to be a needle was actually much more like the haystack. This really gets to the heart of the problem. The entire promise of oversampling is that it creates valid members of the minority class. But what this investigation uncovered is that these techniques often create data points that are statistically more likely to be members of the majority class. They are creating imposters. And let's bring this back to why it matters to all of us. This isn't just a problem for academics. It means that for 2 decades, critical AI systems, the ones that could approve your loan, screen your medical scan, or protect your data, may have been trained using flawed, misleading, or falsified data. The potential for error hidden inside our systems is enormous. This whole investigation leaves us with a pretty provocative final thought. If a technique this widely used, this accepted, and this intuitively correct can be fundamentally flawed, it makes you wonder, what other foundational assumptions in AI are we taking for granted? What else do we need to put on trial?